Hitting record. Okay. So for those of you not here right now, we are doing a sync up between the distribution team for the charts and the geo team to actually figure out how to get geo to work inside of the charts. We're currently looking at charts GitLab issue number 8, and we're going to break that down into a section of tasks that we can actually work on and try to then figure out the MVC that we have from that point forward. Apologize, I'm pulling this up. I was doing a review for one of the auto deploy app guys. Got distracted. I was like, oh, it's 10 o'clock. I need to be on a call. Okay, so this issue has actually been open for around a year at this point, over a year at this point, so it's almost a year and a half. Originally opened way back at the beginning of the charts when we decided we should be able to do this on feature parity at some point, but long ago before it became a priority of any kind. The evolution has been around for a little while when we tried to figure out how to do this. What we have discovered after a couple of discussions across a couple of summits, hilariously, is that the minimum requirements are that we need to actually build a container based on geolog cursor, which is good because it's already in the Rails code base, so we basically need just another container that operates with a slightly modified config and a different entry point. So fairly straightforward. The needs of that container, however, have been a little complicated. We need a separate database geo.yml that defines the Postgres connection for geo to actually behave. That is not necessarily a separate instance of a database, so not necessarily a different location, but just a different actual database connected. So that would have to be 1, available, and 2, well documented so that people know they have to create the second database when they're using an external provider. There is also the requirement of having TLS, which we have had support for. However, I do have my concerns regarding the wall. The wall, for those of you not familiar, is the write ahead log, and that actually handles how we do replication from one database to another. The current directions for installation of Geo actually dictate manual first replication, which is something that we may want to look into if it's feasible to do that with the charts and what the steps will actually be. So that, in my opinion, is definitely going to be a breakdown item. We're going to have to document how to create the databases as well as how to do the first replication. I have not read them in detail recently, so Gabriel, if you can point out exactly what we would need to do.
Sure. Let me just make a question before we go to that direction. Can you explain how the database is handled today in regards to GitLab running a chart?
Sure. So currently the chart 1, we specifically acknowledge that if you're going to use the charts, you really should not use the built-in Postgres chart in production. So anything that would require a wall or resiliency, this is not what the current charts Postgres is intended to do. However, what you have to do if you're going to use, say, Google Cloud SQL is you get connected, you set up SSL, you make the appropriate settings, and then you pre-create the database, and then we will seed the schema and the necessary information during the migrations run. So you don't actually have to populate anything other than the username, the database location, and the database name, and the charts will take care of everything similar to how the Omnibus does.
Okay.
I have no idea what it's about.
So, we have 2 databases. The first one is the replicated one, which whatever external solution you're going to use, that will probably be handled by that. If you're using AWS, there is probably a replication solution for that. If you're using Google Cloud, etc., the same. For the second database instance that you need for Geo, which we usually call it the Geo tracking database, it's a regular Postgres instance, but the only different feature that it has, it requires foreign data wrapper to be configured. So there is we use some conventions on how you call the connection name, etc. But it has to point to this secondary replicated database, the read-only one. So that's the main change that needs to happen to this secondary database. And on GitLab Rails side, there are a few rate commands that you can run to do the schema migration. And also, we after you set up a foreign data wrapper connection, we can do the schema import to the foreign data wrapper reference table, the foreign table. I lost sound. I'm not hearing you.
Sorry. Hard road mute mic. Sorry. Sometimes I forget that I do that. Is there anything that would prevent the use of that with any external providers, or is that entirely held within our own code?
We are testing with Amazon RWS, RDS.
RDS.
Yeah. So we are testing that. We found some issues, but I think it's just configuration issues. So far, I think, at least for Amazon and Google Cloud, we can use foreign data wrapper without any problem. So
Okay,
it's
so
a bunch of configurations that the user has to do.
my laptop is going a little slow. I've got the Google Doc open so that we can take a few notes as we do this. I'm still writing in some headings, so my apologies. Okay, so I'm actually going to see if I can safely copy from here to here.
Can you please put a link to that Google Doc somewhere so that I could get hold of it?
Sure, I've actually gone ahead and placed that into the same thread where I put this meeting link over in Slack, only so that this actually persists there. Those people watching the video will not be able to see it if I put it in the chat. Okay, well that didn't format very well when I copied and pasted it in, did it? Well, this is going to be fun. This is probably the worst I've seen copy and paste. Okay. Thank you for the formatting, Rachel. Okay, so that being said, let's move on to the next items. Gabriel, if you can throw in notes to the FDW while I go ahead and discuss the next pieces from the current proposed solution.
Can I have a link to the doc?
Yes, it's on the Slack thread. I do have it sent there. And there we are. It's also in the Zoom chat if it's easier for you to get to.
Thank you.
Okay, so beyond the database needs, we need to also have the geolog cursor have access to Redis. Now, Gabriel, can I assume that that will be a separate Redis per GeoNode?
Yes.
Okay, so that will be the local Redis to whichever node you're on. Okay.
Yeah, and they don't need any kind of replication.
Right. So if you use memory store or whatever it is Amazon calls it, it's just separate instances local to wherever your clusters are.
Yeah, and I don't know if we provide the Redis as part of the chart as well. But if we do, you can set up Sentinel or whatever you want for the availability as well. But they are separate. They are not connected, the primary with the secondary.
Right. I didn't expect that would be the case, because then you'd have sidekick jobs from the wrong one. That would be unfortunate, to say the least. The application would not know what's going on anymore. Okay, and then the last item, which is a big one that we'll actually have to flesh out, is that making use of geo, all of the secrets and keys have to be replicated between all the nodes. Is that 100% true?
The secrets, yes. You need that first because you need to decrypt it, stuff that is on the database, and you need that also if you're doing failover.
Right. Okay, so that's good. That pretty much hasn't changed. The current documentation is how it's done on the Omnibus, is you spin up one of them, grab the secrets file, and then manually replicate across all of the nodes. That is a little bit different when it comes to how the charts work, because we don't have a secrets file. You actually have to just go, give me all of these secret content so I can go replicate these secrets over here. And we don't actually have that extremely well documented on how you actually do the same secret migration if you're going to run a pair of an Omnibus install and a chart. So that's kind of related in two ways. It's a separate issue, but also one that's going to be required for this use case.
I have a few questions about that. This is kind of tangential to this conversation, but I think it's kind of related as well. One of the things that we are investigating for Geo is the use of console as a service discovery solution, but as well as a way to share a few configurations. For example, the secrets. So that could be something that a hybrid installation that is partial Omnibus and partial Kubernetes could use to share the secrets between each other, or even inside Kubernetes itself. So you don't have to copy and paste.
To see if we can include console, because there are some pluses and minuses to that right now. For console to be able to update the contents of secrets, it has to have the right to update those secrets, so it needs an additional RBAC role. That's doable, especially if it's namespaced. The problem that comes into play is right now there is no specific way to tell it, hey, the secrets have been updated, all the things that use them, go restart, right? So rolling all of the things that would have to use that, we may actually have to build that into the operator to do it correctly. Our operator within charts does not behave as an instance regulating item. Okay, so there's multiple patterns in the operator framework usage. A lot of people have a full instance. You say, I want an instance of, and it goes and creates you an instance and pre-creates everything, and then it individually manages it. Instead of having a chart, you have a chart that deploys the operator, and then the operator actually deploys the thing you want. Ours operates in such a way that you have an operator that is a codified system operator's knowledge, meaning that it will actually ensure that your system runs and rolls all of the things in the right periods of time. We may want to look into the operator actually being required to keep an eye on the secrets, so that when console would then turn around and change the secrets, the operator would go, oh, the secrets have changed. Roll all of these pods because they know about this secret. So, like, if you did it in Omnibus, console would replicate across all of the nodes and update the secrets file, and then it would know, I need to make this call to a shell script that then restarts all of the things. We need to make that same kind of behavior in place, because our console instance that's replicating content should not be responsible for replicating pods, because then anytime we add a new pod, we alter, which one does or does not need Redis, then we'd have to change that as opposed to the codified operator knowledge, which is what the operator does. It replaces that functional framework of how the omnibus behaves when you do that, right? Okay, I've checked that one in there real quick. Yes, I apologize. I type so fast sometimes I forget to spell whole words out. Okay, so there's a link for that. From the very first number of things that we need to do, now that we've run down this one, and I believe we've pretty much covered everything that Gabriel, you and I actually discussed while in Cape Town. Yes. Okay. So let me tap this one right on the nose. If I have two clusters, these two clusters don't have to talk to each other, correct? Because the databases will be their point of contact.
They need to have API access. I think right now it's the secondary that needs to call the primary, and not the other way around. I need to double check that, but it used to be not that the case in the past. But I think today it's just the secondary that access the primary. They need that to do some sort of validation during logging.
Okay, so but it's only the actual API instance communication.
Yeah.
We don't have to worry about another protocol or exposing another port or any of these things.
For the secondary to replicate Git, it has to be able to access Git on the primary.
Okay, again, that's
yeah.
okay. We have that one exposed, so we're good. I wanted to make sure that wasn't anything outside of the normal exposure that needed to be added. So
No.
Okay, great. Then I don't have to worry about that. I had made a comment for those of you following along that may not know exactly where I'm reading from. I had made a comment where I was concerned about requiring exposing the in-chart SQL because doing a TCP port through an ingress load balancer is not ideal, to say the least. However, if you do expose it outside of an ingress load balancer, you now have a separate IP address and a separate host name that you have to manage in regards to the cluster. It complicates the infrastructure greatly. Every time you have to add another port that is not based on HTTP or HTTPS. So noting that we don't have to do that, extremely helpful. Okay, I think we have most of the basic breakout understood. Okay, so let's come back through here. Our actual points, we've covered them, but let's actually say what needs done task-wise so we can start doing issue creations. TLS, okay, the geo log cursor container based on Rails, that's a simple issue, I believe, but it's highly dependent on a bunch of other things. So, yes. Thank you for doing notes, Rachel. You're keeping it much better organized than my brain right now.
It also means that I need to make sure that I'm paying attention because I want to really understand what's happening here. And at least if I'm taking notes, then it's actually going in my ears and out onto the dock.
Geolog cursor container needs the database. Database, the TLS, and that you said that does need wall inside of it? Or is that
Sorry? Can you?
the Postgres needs for this container? I have a listed item that says Postgres needs TLS and wall.
Yes.
But just to be clear, I'm pretty sure we covered earlier that that's not something that's in that container. It's just an assumption that the databases have the ability to do wall.
Yeah, yeah.
Okay.
I think that the main point is not actually the wall replication, because we're not doing any kind of transformation based on wall or filtering. It's just that it needs to be it needs to not be the logical replication. It has to be the regular binary based wall log replication. Just that.
All right. And then that has also the need for the access to the local Redis, correct?
Yeah.
Okay. And then do we have a standard name for the geo database? Or is it just something geo?
In Omnibus, we call it Geo Postgres, but on documentation, we call it Geo Tracking Database.
Okay. As long as I can make clear documentation on, like, name it something that makes sense. By default, for example, you have GitLab HQ production, but you can always change whatever the database name is, right? It's a property, you just set it, it does its thing. So that's just a matter of noting that one.
Yeah, sorry. I think the actual name that we use for the schema is, I think, Geo GitLab HQ production or something like that.
That makes sense. Just prepending it with geo. That makes sense. Okay. Geo does not. I'm actually going to make a comment on the issue in regards to this one in a little bit. I want to make sure that I don't forget to do that, so I'm pre-creating some content there. And region as cluster. Okay, and then we've got the secrets population. You document the replication of the secrets between clusters. Document secrets from Omnibus to. We really need to script this. Okay, so that's a future item. The minimum requirement for that is to actually document what things need to be replicated from the secrets, from the Rails secrets into the application secrets in terms of Kubernetes. Obviously, they're going to have separate Postgres credentials. They're going to have separate Redis credentials, but the necessary bits that is Rails secrets, you're going to need to know how to translate between the two. Okay, so as terms of the primary needs of actually doing this, is there anything that I'm missing here aside from, no, we're missing the documentation of how to do the initial replication, aren't we? Okay.
I just remembered as well that we implemented the Git proxy on the secondary. That proxies, for example, when you do a Git push to a secondary server, it proxies that to the primary. I think this is done on AJ proxy as a configuration, but I need to double check that. So there is one more thing, yeah.
Okay. Yeah, definitely we need to understand how the proxy works. If it's implemented in HA proxy, then, well, we're not using HA proxy. So
yeah, we can consider this like optional for like first implementation or something like that until we figure out that.
yeah, it'll be required for feature parity, but it's not a specific requirement in MVC. What we'll end up doing is doing the MVC, and it'll look like Geo from 4 months ago before the proxy was put in place. So I completely forgot about that.
Yeah, I'll have to sync that with Ash. He is the person behind that implementation, but I'm almost sure that this is done on AJ proxy.
Huh. Yeah, that'll definitely complicate things. Okay. Now, just for notes, I'm going to go back up here in the discussion and put TLS was added in following MR. Okay. For some reason, my brain is wondering what is it that made TLS on Postgres a requirement? Like, I know there's a strong reason. My brain just is like, why was it a requirement? If the two databases don't actually talk, why is it?
They talk locally via foreign vector wrapper. And if you have that in a AJ cluster or something like that, then it may be transing between your network.
Okay, right. So that's it's if we're in control, correct? Like, so if we have the database inside of our chart versus using RDS, do we still need the foreign data wrapper if we're doing Cloud SQL or RDS?
Yes, we do. The thing is, the tracking database is what handles state or geo in a secondary node, and we still need to join stuff with what's actually in GitLab. For example, we need to know if a project is still exists or this kind of stuff. Or based on the list of projects, if we're still missing to replicate the repository on the other side. So the two databases needs to talk to each other.
So the two geo-tracking databases need to talk to each other?
No, sorry. You have the geo-tracking database and you have the replicated read-only, all of that on the secondary node. And these two have to talk to each other.
Okay, I gather that. What I'm misunderstanding is if both of these particular databases are housed in an external Postgres. We're going to want TLS so they can communicate for a safe reason anyway.
Yeah, inside the chart, it's not needed.
Okay. Okay. That's where I was trying to figure out, is if we make the FDW obsolete because it's outside. Okay.
We just make the TLS obsolete, but the FDW is still needed. The reason why is the replicated one can't have any writing data on that. It's just read-only. So we need to write state in another place, and that's why we have this secondary tracking database. So, for example, whenever we sync a new repository, we store state there. We store a checksum and a bunch of other metadata. But we don't have the list of repository. We don't have the list of users at that instance. So that's why we use the other one. If it helps, I can share something.
I'm still not sure exactly how that architecture works. Is there a document that we have somewhere that we can add to these notes?
I don't know. Maybe on the development documents.
That would be fine. It can be added in the future.
Okay.
Just anything that would help, like other people that are trying to follow along what exactly is going on that aren't familiar with it either from my side or your side are going to be like, what in the world are they talking about? And I figure if I'm a little confused, they might be confused.
Okay.
Okay, so ignoring the omnibus behaviors, I'm just trying to understand the infrastructure requirements. If I have a cluster in US East 1 and a cluster in Europe 1, right? And I have an RDS here and an RDS here, and I'm not using replication between the two? This is what I'm trying to figure out. So
No.
Okay.
Let's go back a little bit. You have,
Sure.
Let's say, your primary geo in the US, and you want to have a secondary geo in Europe. So you're running your first cluster in the US, and it's a regular GitLab installation. And in Europe, you're going to run this geo secondary node, which is actually a cluster thing. So the RDS in the US will replicate to Europe. In Europe, you have a read-only version of what you have in the US, and that's how we can, and that's how you can actually browse GitLab from the database in Europe, running Rails in Europe. But to actually hold the synchronization information that you need to take care to be sure that you have everything that you need there, all the repositories and everything that's actually changed. We need to store that information inside Europe in another instance, because that instance you can do any writing operation to it, because it's replicated using streaming replication.
Okay.
So that's why you need this second instance.
Right. Okay. Maybe it's just me not understanding how the application suite then interacts with those databases. This shows that I'm not 100% familiar with how Geo itself behaves.
No problem.
I have pasted the diagram that we commonly refer to inside of that document. I'm not sure if that's helpful, but it just shows where the geo tracking database lives on which node.
Ah.
Yeah,
that
and
much better.
Most of this state information, the starting point is the geolog cursor. So it will iterate over something similar to a wall log file that we implemented inside the database itself. So we read all those pending events that we need to replicate. The glog cursor will schedule things on the sidekick of the secondary node, and sidekick will do all the cloning and updating things, and that job or that bunch of jobs will store the state inside the secondary database. And we actually need to hold the state there so we can provide information to the user via the web interface. So we can say you have 2,000 repositories on your primary, and we have replicated 50% of them. 2% failed because something, and we show you why it failed. And this other 49% is pending update or something like that. So we can have this whole information to the user, and we need to store state to be able to do it.
Okay. So I think I'm not as worried about the database construction as I was. I was like, how are we going to get these to talk right? Okay, so looking at this diagram, my next question comes to object storage. Are we replicating from zone to zone, like as a part of Geo?
Yes and no. So if you're using object storage and your object storage provider has a way to do geographical replication, then you can just rely on that. But if you're have like in location some sort of appliance like from Dell or something like that, then you probably want Geo to replicate, even if it's in object storage. I'm not exactly sure how we are handling that today. I think if you are using object storage, we just don't replicate that. But there are situations where you actually want to Geo to do that kind of replication. Well, yeah. So we probably, if we are not doing that yet, we probably need like a switch, a feature switch or something like that.
Okay, that's something we're going to want to investigate and make sure that we document. A lot of people who deploy into one of the public clouds will have the ability to do replication between the various zones, right? GTS, S3, DigitalOcean spaces all have this functionality. But in some cases, you actually have to turn that on specifically. So like we want to say, if you're going to use S3 with EKS, then you want to make sure that you're replicating across the continents for these buckets. Otherwise, you're going to have the implication of you have local access to anything on Git, but anything else, LFS, uploads, traces, is still going to be slower because you now have to go across the ocean either way. Right? So we're going to want to make sure we document that. It's not a hard requirement right now, because we can easily POC this on, use a cloud provider. But we should also look into consideration of, for those people using on-site or using just doing a full proof of concept with MinIO, that those two nodes have no way of replication. So we'll have to make sure we document how that method works so that they understand exactly how the object storage will replicate. And the next item I see is repositories and wikis and Git content. This does not surprise me at all because, like we said, this is over HTTPS, so it does the proxying for you. It still comes down to that Git push proxy and understanding exactly how that works and what's involved there. So we will need better clarification on that one. Whether that's just an external link so we know how it works, that's fine. But like Gabriel and I have already said, it's not a hard requirement for MVC. Okay, so geolog cursor container. That actually looks fairly straightforward. Where did I leave my tabs? Here we are. My laptop is struggling to do this and Google Docs and record. So my apologies if I have to click and wait. All right, so we already have issue number 8, which we're actually basing off of. Hit the new issue button and see how badly my computer lags. Okay, so we need the geolog cursor container. We need the documentation of the production, the GitLab HQ Geo production database, and documentation of how to do the initial replication. Now, is that the initial replication? When I say initial replication, what am I talking about for those in the crowd?
So basically, there are 2 steps. First, you need to replicate the database. So it's basically dump and restore.
Okay.
There are a few things that you need to do before, like you need to enable Geo. So we start to queuing events that will be replicated on the other side. So after your queuing events, then you do the initial database replication. GitLab, the secondary node, will start to backfilling everything that is not database related. So all the repositories, all the assets, logs, etc.
Okay, and I did tack in one more thing here because I just realized we didn't actually go, we should actually document the fact that we need to be able to configure all of this once we have everything else in place. We have to be able to tell it if it's a primary or secondary node. Kind of required. It's one of those little tasks that actually is, super important that you just kind of assume will get done, and we didn't put it on the task list.
And do we have to have anything in terms of monitoring, or is that completely separate?
That's a question I don't actually know the answer to. It might be something that's required for monitoring. Do we do anything with Prometheus on that at all? From the Omnibus side, I'm not sure. I think that'll be tack into an investigate. Yeah, do we need that? I'm not worried about metrics on the MVC. I mean, if there are supposed to be metrics, I want to know, and I want to put them in place, if so, but I'm not as worried for just, look, it works. Okay, giving the current item in the document that says task list, is there anything that you think might be missing, Gabriel?
Let me take a look.
Sure thing. And if keep in mind that I don't mind if it's missing from your side or my side, I don't care. Just want to make sure we have everybody covered.
Yeah, I will probably have to reread our setup instructions and see if something pops up from there. But from what I've seen so far, I think we are covered.
Okay. So quick summary for those following on the video. We've come down to the following list of tasks. We need to create a geolog cursor container that needs to have database access to the GitLab HQ geo production database, and only that. And then you also need to have access to the instance local Redis. The database will need to be created, which is the GitLab HQ geo production, aka the geo tracking database, which is separate from the primary GitLab HQ production. And this should be within the same region as the cluster. We need to document that because we have to worry about the initial replication, especially if you're on-prem. We have a few notes in the document about exactly what needs that, but currently there is at least one manual step. We have to document and possibly in the future script the replication of secrets between clusters, specifically the Rails secrets, and I believe that's it, correct? Just the Rails secrets?
Yeah.
Okay, and we should also document the replication of the secrets between Omnibus and Kubernetes or vice versa. We do already have people making this migration via restores, but we should document it better for people that are going to be setting up paired instances like this. We need to add the configuration controls to actually turn on geo and specify whether or not is a primary or secondary. We need to, in the future, investigate Git proxy and how this works. It's not a requirement for the MVC. We need to investigate and document object storage replication so that people know the difference between on-prem and cloud service providers. We also need to investigate if monitoring is required for the geolog cursor or the database thereof, and that is not a requirement of the MVC. We also need to document the tracking databases for data wrapper usage so that we better understand as a whole how this behavior actually works. I believe that covers everything. Did I miss anything? Okay, now with that in mind, let's go ahead with the next steps. Obviously, the first next step is to take all of those things and break them down into actual actionable issues within the charts. Primarily, maybe the documentation of the FDW would be over on the geo side. And I think Git proxy definitely needs to be over on the geo side. But all of the rest of that would be to go and create the necessary task list. Now, Rachel, correct me if I'm wrong, but we're currently aiming for the MVC in 11.11.
That would be nice if we could do that for 11.11. The plan was to do all of this investigation and to determine what needs to actually be done to mark this as closed, figure out how much work that is, and schedule it in for either 11.11 or spanning 11.11 and 11.12.
Okay.
So let me make a different question here. For the Git proxy, thinking about how to actually implement that with Kubernetes in mind, can you give us like a roughly idea of what should be done that would make it easier for Kubernetes or something like that? I'm not sure if this is a simple question or not, but
it's one of those things where it's unfortunately hard for me to answer immediately without actually looking further into the details.
So let's make it conceptually. If we have something that handles Git, like a Git daemon or something like that, and if that that daemon do the split between going to Italy in a local instance or going to the Git interface on the other cluster as a regular user via HTTP. Would that be doable inside Kubernetes? Are you seeing any type of any concern or something that would complicate that?
I don't see anything immediately, because we're talking basically about Git push over HTTPS, correct? Okay, if we're talking about Git push over HTTPS, I see no real implication that does the controlling of what goes where. We do need to figure out how Git proxy works, but if we have to add another daemon in place, that's technically feasible. But that would be related to the Unicorn and Workhorse APIs, so I don't really see a problem there. If we somehow had to put something in place on an SSH path, that would get complicated pretty quickly. But that's not too much of a concern. Adding in the actual geolog cursor container should be relatively straightforward and should be something we can manage to do in 3 days. And that's with, framing, testing, bolting it in. So I don't see anything here that should be horribly hard to do. It's basically making sure that we can actually replicate what we need inside of the chart, and that requires a better understanding of exactly how all of these things interplay. And as somebody on the team comes in and actually starts doing the physical work, we'll get a better picture over time on how long that's actually going to end up taking. Do I think this is feasible by the 12.0 milestone? Yes, by a long shot. It's quite possible that we can get everything in by the 12.0 milestone. I can't say that as a hard promise, but I don't currently foresee a problem with that. Okay, I don't think I have any further questions at this point. Obviously, this is our next thing, and we'll get everything created. The order of scheduling will be relatively straightforward. It'll be the clearing of the documentation. It will be the creation of the container and the creation of the databases. That's pretty much straightforward. Gabriel, I do have one question, just because the first thing we'll be doing is doing this with a cloud provider, will the manual replication be necessary if you set up this replication with a cloud provider that has the ability to do multi-zone replication?
No.
Okay, so
yeah,
plus side is that manual step does go away.
Yeah, if they can provide exactly clone of the replication, then that's not needed.
Okay. Right. My brain was sitting there going, why do we need to manually replicate if it replicates for us? Awesome. Okay, we are at 56 minutes on the meeting. I don't think we have any further questions, and our timelines at this point are pretty much create the issues and break down clearly which ones are required and the ordering thereof.
So who will take ownership of creating those issues?
I will take care of all the issues on the chart side. Gabriel, if you can create the issues for clarifying documentation on Git proxy, the object storage replication, and the FDW behavior.
Okay.
I'm just moving them into different areas based on who's going to be taking care of what, just so that we can keep track of that.
Yeah, I was just about to do the same thing, so you're ahead of me, just a hair.
Well, Jason, if you can just take out the ones that are yours while I'm finding the ones that are Gabriel's.
That is actually pretty much what they are right there. Oh wait, we lost one. We lost one, which is the documentation of the FTW behavior. Or should I say clarification of the FTW and how it works. There we go. Okay. All right. Thanks, Gabriel, for sitting with me and helping me work out all the details of what we need to do and clarifying my many questions.
Thank you very much.
Okay, thank you.